So in exercise 7.1, there are 6 questions. If you have any doubts, you can ask. You can speak up and ask your doubt.
So question number 5.
Question number 5. Okay, let us see. And yeah, one more thing. Actually, I told you on the last one also, some construction work is going on near my house. Okay. So there may be little bit disturbance. And this is only discussion class. We'll be completing all these exercises. We'll complete the discussion. Next time we are going to start complex numbers. Okay.
Excuse me, sir.
Yes.
Sir, can you wait a minute?
Yeah, sure.
Okay, sir, continue.
All right. So let's solve this question number 4. A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? All right. See, you might have done such type of question in class 10th as well. There was this chapter called probability where there were questions of coins, dices, etc. So we can do it in 2 ways. One is like actual counting. There is a coin, all right, and it has been tossed up 3 times. So we have to record the outcomes. So what we can do the actual counting. So in actual counting, what will happen? We will discuss the various cases which are possible here. So first case is HHH, which means that we are getting head every time when we toss this coin. This is one of the possibilities. Or it can be tails all the 3 times. What else? Head on the first toss, tail on the next 2. Then we can do some arrangements here, like tail can come at the first place, then head at the second, and tail again at the third. Then it can be TTH. All right. T stands for tail, H for heads. So after that, there can be 2 heads. So HHT, HTH, and THH. We can make it simpler. First, I will write only those cases where only one head occurs. Okay, that will make it simple. First, I will write those cases where only one head occurs. This can be done in 3 ways. H, depending on the position of H, depending on the position of H, right? Either head can come on the first turn, or it can come on the second, or it can come on the third time, right? Then we will discuss the cases where 2 heads can appear. So it can be HST, or it can be HTH, or it can be THH. So next 3, and then there can be 3H, or there can be no H at all, right? So based on this we have 8 ways. So this is one way to do this question. Another one can be the multiplication theorem. This is your method 1. This is method 2. Multiplication theorem. So by multiplication theorem, we will say number of ways or number of cases is equal to 2 into 2 into 2. Why? When you toss a coin for the first time, either head or tail can come. So there are 2 ways. And when you toss it again 2 possible ways are there, head or tail. And same is true for the third one. Any one of them can come. So because of that, by multiplication theorem, I can say that the number of cases will be 8. Similarly, here you can remember one important point. This can help you in some other questions. If a coin is tossed n times, if a coin is tossed n times, then number of outcomes or number of cases will always be 2 to the power n. Why? Because here we are having 3 coins, so it is coming 2 cube, right? 8 is 2 cube. If 4 coins are there, then the outcomes will be 2 into 2 into 2 into 2 4 times, that is 2 to the power 4. And similarly, if a coin is tossed n times, it will be 2 to the power n. Okay. So you can generalize this concept also. So this was question number 5. Now do you have any other doubt in this exercise? Anyone having any other doubt in this exercise 7.1? I hope you have solved this exercise and that is why you are not asking the questions. No one is going to come and solve for you, okay? So if you are not solved it, I don't know what is the reason. Anyways, I am moving to the next exercise. Exercise 7.2. In this exercise, which one?
Fifth.
Fifth question from 7.2 exercise, okay?
No, sorry. Open the wrong.
No problem. 7.2 is easy, but still you can ask. It is okay. 7.2 exercise.
Nothing from 7.2.
Yeah, I think because they are very easy questions. Yeah. All right then. Let us come to the next exercise 7.3. Exercise 7.3. There are 11 questions. You can ask your doubts.
So in 11th, third part.
Okay. All right. Any other doubts? I will be
So
first
the
writing
fifth
all
one.
the fifth one. All right. Yes. Any other question? Exercise 7.3. Any other question? Do you have doubt in any other question? All right. Let us first see question number 5. From a committee of 8 persons, in how many ways we can choose a chairman and a vice chairman? Assuming one person cannot hold more than one position. Okay. Okay. So anyone solved this question? Because only one student has asked it. It may be doubt of others as well. But is there anyone who has solved this question? Number 5 and can tell me how to do this? Can anyone explain? Question number 5.
So
8th question I'll be telling. Yes. Can anyone explain question number 5?
So 8P2.
8P2. That is
I
absolutely
said
correct.
8P2, not question 8.
All right. Okay, you are giving the answer. All right. So 8P2, this is correct. This is absolutely correct because
That's permutation.
yes. Now you might be wondering why not selection, why permutation, right?
Yes, because they said choose.
Yes. So this word is okay, but do you think that only a particular person will be becoming a chairman? They can interchange their positions also, because see, it has been mentioned that only one person cannot hold more than one position. That means a person cannot become a chairman and a vice chairman at the same time. But when we say 8C2, that means we are selecting two people, right? But what
Yes, sir.
about their positions? What about their positions? I mean, who will become a chairman and who will become vice chairman? So what I'll do, there are two ways. We can solve this question by two methods. Sorry, this is method one. In method one, what you will say that sir, we have 8 people and we want to choose, so that means selection is coming. So two persons can be selected in 8C2 ways, right? But then after selection, I will multiply this result by 2 factorial. What is the reason? See, whoever you have selected two persons, okay, let's say the persons are A and B. Then will he become chairman or A will become vice chairman? You cannot decide. Alright, so there are two possibilities. A can become chairman, then in that case B will be becoming vice chairman. And if B is chairman, then A will be becoming vice chairman. So that is why into 2 factorial. And what happens? When you simplify this result? Okay, this gets cancelled, and this is nothing but directly you can say it is 8p2. So it is kind of arrangement. 8p2 itself is 8 factorial upon 6 factorial. So both are same. That is the reason. If like they do this thing that only the particular person will be becoming the chairman. If they put this restriction, okay. If they mention that a person is becoming chairman, there's no doubt about it. Then you cannot multiply it by 2 factorial. In that case, it will be becoming a case of combination and not permutation. Okay. I hope you might have understood.
Yes.
All right. So this is your question number 5. Okay. Now question number 11. In question number 11, you want to find the third part. All right. In how many ways can the letters of the word permutations be arranged? All right. Permutations. This is the word. And what is the question? There are always 4 letters between P and S. Okay. There are always 4 letters between P and S. Not all the letters, just 4. Okay. So between P and S. So whenever you will write their permutations, okay? Whenever you will write their permutations, there should always be 4 words in between them. Like for example, this word will be the example of this answer. For example, P is there, then ERMUS. Then you can write the remaining terms like TA, TIUN like that. Okay. So these four are present between P and S, and they are not saying that S will come first or P will come first. So I can interchange their positions like this. Still, 4 alphabets will be there between S and P, and S and P can be somewhere in midway also. So in that sense, they are asking how many such arrangements of this word are possible where exactly 4 letters will be coming between P and S. Okay. So what do you think? How we can solve? Anyone? This is a good question. How we can find their arrangements such that between 4 alphabets, between these 2 alphabets P and S, 4 alphabets are always there, and exactly 4. How can we do this question? Yes, anyone?
So we can find out in how many ways P and S, in which positions P and S will be there.
So how it's possible by actually writing all those places?
So yeah,
But then, I mean, you want to say that P can be here at the first position, S at the second, then P at the first, S at the next position, like that?
yes sir.
Okay. So that will give you the number of ways where P and S can be present, right? But there is one
Yes,
more problem. There are two T's which are similar. This is also one of the problems here. So how to fix that? Okay, let us do one thing. Let us write this word again. Permutaions. Okay. Let us write their positions. One means first position. Second, third, fourth, fifth. This will give you an idea. 6, 7, 8, 9, 10, 11, and 12. Okay. So overall, 12 alphabets are there. So 12 positions will be there, right? Now, what is given? There should always be four letters between P and S. Four letters between P and S. Then, as he suggested that let us write all the possible numbers or the positions where P and S can be present. So, possible places of P and S are P and S are. If P is at the first position, listen carefully. If P is at the first position, then S must be present at the sixth position. Okay. Why? Because in that way there will be four alphabets present which will be present at the position 2, 3, 4, and 5. Similarly, possible place of P can be second one. In that case, S will come at the seventh position. P at third, it will come at eighth. P at fourth, it will come at ninth. P at fifth, S will come at 10. Then 6, 11, and finally 7, 12. At the max, P can be here. Why? If P will be at the 7th position, S will be present at the 12th position, and that sense also there will be four alphabets between them. Now no more possibility. P cannot be at the 8th position. In that case, S must be present at the 13th position, which is not there because there are only 12 alphabets here. So possible ways of their presence equals 7. Do not write 7 factorial. 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now, also, P and S can be interchanged, as I was saying, because it is not written. We have already taken this example. See here. Word is starting with P, then there is S somewhere. Word is starting with S and P somewhere. So basically, these two can interchange their position also. So whatever I have written, whenever I have taken P earlier and S later on, now these two can be interchanged. So also P and S can be interchanged. As a result, now number of possible ways are 14 because there are 7 other ways. In that sense also, S and P, they will be having 4 alphabets between them. Now, this is about P and S. Last step, this is about P and S, but what about remaining? What about remaining alphabets? They should also be arranged. Okay. We have arranged P and S till now. We have
So 10
arranged
factorial.
No, not 10 factorial. Just slight mistake. I will tell you why. Now, we have only rearranged P and S, alright? But we are not saying what about the other 10 alphabets. P and S can be, sorry. So, number of ways, it will not be 7, it will be 14. Why? 7 are the ways for when P starts, when P is there at the P is coming before S, and 7 ways when S is coming before P, right? So because of them, 14 ways are there. Now I said P and S are okay. Now what about the remaining 10 positions? There we have 10 alphabets. You said we can arrange them in, you said that you can arrange them in 10 factorial ways, but there is a slight mistake. They can
So
be
T
arranged
is
in,
twice, no?
yes, right. So they can be arranged in how many ways? 10
10
factorial.
factorial by 2 factorial.
Right. 10
So 10
factorial by
factorial by
2.
2.
Because see, there are two T's, right? That is why. Otherwise, your answer 10 factorial was correct. Now, finally, total arrangements. Total arrangements will be coming when you will arrange P and S as well as the remaining 10 alphabets. So the answer will be 14 into 10 factorial by 2, and this will be some number, okay, some big number, 7 into 10 factorial. So even if you want, you can leave it here, or there may be some answer, okay, you can match it later on. So it will be 7 into 10 factorial. So I hope you might have understood this thing. Yes. Anyone having any problem still in this question? Do you have any problem, or is it clear?
So now we got 10 factorial by 2.
10 factorial by 2. See, because you have only blocked P and S, right? In the earlier part of the answer, you have only blocked P and S. But what about, and you are saying that some random 4 alphabets will be coming there in between them. That is okay. But ultimately, that is like arranging remaining 10 alphabets. Let's see how. Suppose that you have P and you have this word S. Let us say you're writing ERMU here. Okay. ERMU. How many of these are there? 4. And you have written 6 alphabets. How many of them are remaining? TATIUN. 6 more are remaining. So basically it is like arranging these 10 alphabets. Then in place of ERMU, any 4 TATI can come, but that will not make a difference. Ultimately it's like arranging 4 plus 6 alphabets in a line, right? So out of these 10, 2 of them are same, T and T. And what I told you, whenever identical objects are there, then we divide the answer by, in the numerator it is total number of objects factorial divided by factorial of the alphabets which have been repeated, or the objects which have been repeated. So T has been repeated twice. So that is why 10 factorial by 2. And hence we multiplied by the arrangements which came from the arrangement of P and S. Okay, that's the reason. So 10 factorial comes from the fact that we can arrange 10 objects in a line in 10 factorial ways. Why we divided by 2? Because 2 of them are same. That's it. Rest everything has been covered in these 14 cases where P and S are shifting their positions with the constraint that 4 alphabets are coming between them. Now, between P and S, there are no particular 4 alphabets. So you won't say, sir, I will arrange these 4 and then I will arrange these 6. So it should be like 4 factorial, 6 factorial by 2. No, because these 4 can be any 4 alphabets out of these 10. That is why. So it is like simply arranging 10 alphabets in a line and then you multiply by the number of objects which are same. That's it. Now, anyone having any doubt in this particular question? Okay, then any other doubt in exercise 7.3? Exercise 7.3, any other doubt? Okay, then let us come to the next exercise 7.4. Exercise 7.4.
So 6 and 7.
6th and 7th. Okay. Yes, any other doubts? Exercise 7.4. 6th,
So
7th,
ninth
and
one.
9th one. Yes. Apart from these 3 questions, any other doubt? All right. Let us start with the 9th question first.
So fifth,
Fifth
fifth and
one.
eighth.
5th and 8th. All right. So you are finding little bit difficulty in combination. Okay, no problem. Okay, let us start with question number 9 first. See, in question number 9, it is given that it is, the question is, in how many ways can a student choose a program of 5 courses if 9 courses are available and 2 are specific, 2 specific are compulsory, right? Let us name these courses as C1, C2, C3, C4 and like up to C1. We have these 9 courses, okay? A student has to select 5 of them, but 2 of them are compulsory. 2 particular, not any 2 of them, 2 particular. For example, let us say these 2 are compulsory subjects or compulsory courses. So basically the student is not having the choice. He or she cannot ignore these 2. They are compulsory. And total choices available are 9, but actually effective choices are available that are 3. But ultimately he has to pick 5 subjects or 5 courses. So number of ways in which a student can select, number of ways in which a student can select 5 courses. So first of all, 2C2. Who can tell me why this number 2C2? Question is not, answer is not complete, but just this part. 2C2 and then I am going to multiply it with something. So from where this term is coming, 2C2, can anyone explain?
So the compulsory courses.
Right. So there are these 2 courses and you have to select both of them. So this can be done in one way and 2C2 will come out to be 1 only. 2C2, 2 factorial, 0 factorial, 2 factorial. This value will be 1. So otherwise also it is very logical. So 2C2. Now how many options are remaining? 7. 7 are remaining. 2 has been selected. So now they are not available again. So C1, C4, C5 like up to C9 these are available. And out of these 7 you have to basically select 3. Why? Because overall you have to select 5 objects or 5 courses. And selection, not permutation here, right? You are just selecting the course. You are not arranging them. Okay, arranging won't make any sense. So this will come out to be 1 into 7 factorial, 4 factorial, 3 factorial. This value you can write 7 into 6 into 5 into 4 factorial, which we can cancel from here, and 3 factorial is 6. This will be cancelled. So 35 will be the answer. Okay. So 35 are the total number of ways in which the student will be selecting C2 and C3. And apart from that, the remaining 3, okay, that will make a combination of 5 subjects. So this is the way to solve question number 9. Why multiplication is coming? Because he cannot select 2 subjects from these or 3 from the remaining. No, not or, the word and is coming, right? And means multiplication. This is your question number 9. Okay, then. Okay, please just hold on for a second. Yes. Now let us solve next question. Okay, eighth one. Eighth one is easy. So in question number 8, A bag contains, we have 5 black balls and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. Straightforward question. Number of ways. I'm not writing the whole thing. Okay. You are just going, you are supposed to just repeat that sentence. Number of ways in which we can select 2 black and 3 red balls. Now 2 black balls can be selected in 5C2 ways. Because how many black balls are there? 5. And you have to select 2. How many red balls are there? 6. You have to select 3. And clearly the word and is coming. So into, this is your answer. 5C2. Use the formula of NCR, which is n factorial by n minus r factorial into r factorial. Alright. And by using this formula, 5C2 will come out to be 10 and 6C3. This will be, I think, 20. 6 factorial 720 by 6 into 6. Yeah, 20. So 200 will be the answer. So there are 200 ways to select 2 black balls and 3 red balls out of these given number of balls. Then a similar kind of question, that is question number 5. Find the number of ways of selecting 9 balls. Okay. So 6 red balls are given. 5 white balls are given. And 5 blue balls. Blue balls. And basically we have to select 9 balls. We have to select 9 balls. Considering the fact that each selection must contain 3 balls of each color. This can be completed in a single line. Must contain 3 balls of each color. So basically we have to find the number of balls. So that can be done in a single step. So number of ways. So previous question was also like that. We have 6 red balls, 5 white balls and 5 blue balls. Okay, we have to select 9. Total number of balls to be selected are 9. These are the choices available. But there is a constraint that you have to select 3 balls of each color. So then it becomes a simple question. Okay, who can tell me what will be the answer?
The 6C3, 5C3 and 5C3.
Very good. 6C3 into 5C3 into 5C3. 6 red ball you have to select. You must select 3 red balls. That is asked in the question. So 6C3. Then from 5 white balls you are supposed to select 3. You cannot select 4 or less than 3. Why? Each selection must contain 3 balls of each color. Similarly, from the 5 blue balls you will be selecting 3 and you will do multiplication. Why? Because you have to select 9 balls in all. So this will come out to be 20 into 10 into 10. So the answer will be 2000. This will be the answer. Now question number 7. In how many ways one select a cricket team of 11 from 17 players in which only 5 bowlers can bowl if each cricket team of 11 must include exactly 4 bowlers? Easy question. So basically we have 17 choices. There are 17 players and we are supposed to make a team of 11. Okay. Out of these 17, out of these 4 are specialist bowlers. 5 players are bowlers. 5 players are bowlers and cricket team is to be selected. And what is given? What is the restriction? Must include 4 bowlers. must include 4 bowlers. So on the basis of that, we have to give the answer. So number of ways in which a cricket team can be selected with the restriction that there are exactly 4 bowlers, provided there are 17 players, and out of these 9 are the bowlers. Sorry, 5 are the specialist bowlers. We have to make a team. That means selection. Okay. So again, it becomes another easy question. Who can tell? Aradhya, can you hear me? Can you give the answer? I hope you are there in the class. Can
I'm
you
there,
give
sir.
answer? All right. Can you try? It is easy. Can you give the answer? We have to select 11 players. 17 are there. And out of that 17, 5 are bowlers and we have to select 4. So answer can be given in a single step just like the previous questions. Can you try? It is easy. You can try. Let us see what is the misconception. If there is a wrong answer, we'll see what is the problem in that answer. Anyone else? Girls? Anyone can try. What is the problem? Do not worry about the wrong answer. That is okay. You will make mistakes, then only you will learn. Anyone else would like to try?
So
5
5
C,
C
5 C,
4
4.
into
That is
12 C
correct.
7.
Wait a minute. Why 5C4 is correct? Because see, there are 5 bowlers, right? You must select 4. So first of all, do not write 17C4. That will be wrong. Why 17C4 is wrong? Because if you think that all the 17 are bowlers and you are selecting 4, then it becomes wrong. Out of 17, only 5 are the bowlers. But in the team, we need only 4 bowlers. So first of all, out of these 5, we select 4. Yes, now you can continue.
So 12 C 7. So into 12 C.
12C, absolutely correct. Good. Now, actually, out of 5, you have selected 4, and now you cannot select another bowler. So, basically, now how many options are remaining from where you can select? 12. Why? Because now you will not consider the 5 players, which are particularly bowlers only. So, out of those 5, you have selected 4. Now you are left with 12 options, not 13, 12. And out of 12 you must select 7 players. Why? Because you are supposed to make a team of 11. Over. Why multiplication? Because bowlers and remaining players, whatever they can do batting or their all rounders, whatever. Okay, so this is it. This will be the answer. Now you can use this formula of NCR and find their values. That is not important. Okay, so this was your question number 7. Now finally, the last question, that is question number 6. Determine the number of 5 card combinations out of a deck of 52 cards. They are those same playing cards. You might have solved questions on cards in probability also. So 52 playing cards are there. You are supposed to make a combination of 5 cards provided there is exactly one ace in each combination. Okay. So basically it's like you have to select 5 cards, right? There are 52 cards lying on a table and you are like randomly selecting 5 cards. So it should be such that there should be exactly one ace in that combination or selection. Okay. In how many ways we can do it? I think you can just directly write the answer. Yes, can anyone tell me what is the answer? Exactly one ace. It is like similar kind of question. Just replace players by cards. Okay. Instead of players, now we have cards. Instead of bowlers, we have ace. So it's like that. Yes, you can give me the answer.
So 4C1
Yes.
into 48C4.
Yes, that's it. Finish. Because now you might have understood the previous question, so it will become easy to solve this one. There are 52 cards. Out of this, yeah, there should be a basic knowledge of cards, which I think everybody knows these days. Playing cards. There are 4 aces, 4 kings, 4 queens, like that. Okay, then jack is there. Then 10, 9, 8 numbers are there, right? And they are colored cards. So some of them are red, some of them are black. So everybody solves probability in class 10. So all of you know about this thing, right? So there are 4 aces actually in a deck of 52 cards. But you are supposed to select only one. How can this be done in 4C1 ways? Why? Because either you can select ace of hearts, or you can select ace of diamond, or you can select ace of club, or you can select ace of spade. So basically 4 ways. So
Excuse
this
me,
is
sir.
yes.
So what do they mean by determine the number of 5 card combinations?
That means you have to select 5 cards. That's it.
Oh, okay, sir.
Basically, you're not rearrange. You're not arranging the cards. No, you have some cards on the table or somewhere, and you have to just pick 5 cards. That's it. Okay.
Oh, okay.
Combination is selection. Combination is choosing something, selecting something. All right.
Okay, sir.
So yeah. So 4 aces are there, and I will select only one because that is what is given in the question. Now we have 48 remaining cards, and out of those 48, we will select 4. Why? Because in all we have to select 4 cards. Sorry, 5 cards. Multiply them. Okay. This will give you the answer. So 4C1 is 4 only. And if you think that the number is very large, you can leave it here only. That is also fine. But if you think you have time and calculation is not even that tough, so you can write the actual number. So that is 48 factorial, 44 factorial, 4 factorial. So using property of factorial, we can rewrite it as 48 into 47 into 46 into 45. After that, 44 factorial will come, which will cancel the denominator. And the denominator, we have one more term, 4 factorial, which is 432. So this will be cancelled. Then do the remaining calculation. This can go by 16 times and this one 23 times. So this product 16 into 47 into 23 into 45. These many ways are there where you can select 5 cards out of deck of 52 cards such that each combination has exactly one ace. Okay. So I think that's it. This was 7.4. Any other doubt in this exercise? Any other doubt from this exercise? All right. So let us do one thing. It's 4:50. Okay. For the next 20 to 25 minutes, it will not be a very lengthy class because discussion is over. For the next 25 minutes, I am going to write some questions here. Let us do some practice, more practice on this chapter, and that will be it. Okay. Next class, I am going to start complex numbers. Okay. So here is the question, and you can try. Okay. You must try. All of you must try these questions and try to give the answers. How many numbers greater than 1 lakh can be formed? Wait a minute. So, how many numbers greater than 1 lakh can be formed? Units 1202424. This is the question. Let me check the number once again. Wait a minute. Yeah, actually the number is not 6 digit, it is 7 digit number. You add 0 also. Now this is the number, so 10 lakh. So how many numbers greater than 10 lakh can be formed using these digits? Now you can see that 2 is repeated 3 times, 4 is repeated 2 times, then there is 1, 0 and 1 is also present 1 time. So with these digits, how many numbers you can form which are greater than 10 lakh? No other digit is to be used, okay? Only these digits which are given here. Yes, can anyone tell me how to start this question? Like 10 lakh is a 7 digit number, right? It is a
And
7 digit number. We have these 7 digits. How to start the question? Yes, anyone? Obviously, I cannot say that if I will form any number with these digits, it will be greater than 10 lakh. Obviously, no. Like the number cannot start with 0. If the number will be starting with 0, it will not be actually a 7 digit number. Because see, if I write 0100 and we say that is number, right? Then I will read it as 100 and not 0100. Okay. So 0 before a non-zero digit is insignificant, right? So then it will become a 3 digit number. So I cannot start any number from our answer which will be starting with 0, right? So then how to deal with this question?
So first find total number of.
First find the number of
So total.
total number of numbers. Okay, let us say I calculated total number of numbers. Then what?
So and subtract it from the one starting with 0.
All right, that can be done. Good. So what he's saying, first of all, he's saying that you write all the numbers, you find all the numbers which can be formed by them. So 1, 2, 0, 2, 4, 2, 4. Let us write all numbers formed by these digits. All numbers formed by these digits. All numbers formed by these digits will be how many? 1, 2, 3, 4, 5, 6, 7. 7 factorial upon. There are 3 2's and 2 4's. So 3 factorial, 2 factorial. Okay. This number will be 7, 6, 5, 4, 3, 2, 1. In the denominator it will be 3, 2, 1 into 2. Let us cancel it. So this gets cancelled, this gets cancelled. And the number will be 35 into 4, that is 140, 140 into 3. 140 into 3, that will be 420. Alright, so these are the total number of numbers. I am not saying 6 digit, 7 digit, nothing. Now from these we subtract numbers starting with 0. Subtract numbers starting with 0. Because actually when a number will start with 0, so technically it will be less than a 7 digit number. Why? Because when a number starts with 0, actually we'll count it as a 6 digit number. Because if 0 is there, what else is remaining? 222, 441. So basically you have 0 fixed and You want to fill these 6 places. So this can be done in number of ways 6 factorial by, because only 6 places are remaining, because we are starting the number with 0. So this is 6 factorial divided by 3 factorial, 2 factorial. 3 2s are there and 2 4s are there. So this will be 720 by 6 into 2. So 60. 60 will be remaining? Yes. So our answer will be required numbers. We will subtract. 360 will be the answer. So this is absolutely correct. Because what he said, first of all, let us find all the possible numbers which can be formed by these numbers. And out of these total, let us subtract those numbers which start from 0. So obviously, all the numbers which are starting from 0, they will be technically 6-digit number. So they will be less than 10 lakh. Alright, they will be less than 10 lakh. So now 360, what is this? 360. 360 are the total number of numbers which can be formed with these digits, and they will be definitely greater than 10 lakh. Okay, this is the explanation. Let us take the next question. There is this word assassination. Okay, and the question is, in how many ways can all the letters of the word assassination be arranged so that all the S are together? We have solved such type of questions in previous classes. All the S are together. This is the question. It must be easy for you. That means you can give the answer. Yes, can anyone try and tell me how to start this question? Yes. How many alphabets are used? 13. And I have written all the 13 alphabets here such that similar kind of objects are written together. 7, 9, 13. Yes. Just T. We have to keep all the S together. Arrangements are asked here because what is the question, in how many ways can all the letters be arranged such that all the 4 S are together? Yes. Now it becomes easy. We will consider this as one object or one unit. So now can you tell me what will be the answer? Number of ways to arrange these terms? Yes, anyone?
So 9 factorial.
Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 or 9?
Yes, 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 sorry, sir. 10 factorial.
Alright, 10 factorial. Then what else?
So divide by 3 factorial, 2
Okay,
factorial, and 2 factorial.
good. So basically, when we treat this 4s as a single object, so this whole circle is treated as one alphabet. As a result, now you can see that there are 10 alphabets present here. 4s are counted as one. So 3a's, then this circle 4, 5, 6, 7, 8, 9, 10. Out of these 10, 3a's are similar, 2 i's are similar, and 2 n's are similar. That is why we have written this result. Do we have to multiply it also by some number? Should I write into also? What about the arrangements of s within the circle?
So we can write 4 factorial upon 4 factorial.
Very good. Yeah, we'll multiply, but it won't change the answer. Why? Because within these circle, these four can interchange their position among themselves. In this way, they will be together. Okay, they will be together, but they can be shifting among themselves. But there will be no effect, as all the four s obviously are similar. So four objects can be arranged in a line in 4p4 or 4 factorial. But here we are dividing by 4 factorial also. Why? Because all four of them are identical. So that's it. This is the answer. 10 factorial by 3 factorial, 2 factorial, 2 factorial. This is the answer. I am taking these questions from the miscellaneous exercise of this NCERT only. Okay. Even you can try these questions. They will help you. Okay, next question. How many 6-digit numbers can be formed from the digits 0, 1, 3, 5, 7, 9, which are divisible by, and no digit is repeated? And no digit is repeated. So basically, these are 6 digits. All right. You have to form 6-digit numbers from these digits such that no digit is repeated. That means you can use only these given digits, 6 digits. All right. You have to form a 6-digit number, and now it must be divisible by 10. Okay. So it must be easy provided you know how number divisible by 10. Okay. In that way. Yes. We'll try.
So 6 ways, 6 factorial.
6 factorial.
So no,
6.
there'll be 0 will be at the end, and then there'll be 6 slots.
6 slots. Sure.
5 slots, five.
Then what will be your answer?
So 5p5.
That means 5 factorial. Now it is correct. Good. See, first of all, you are given these 6 digits, and out of these 6 digits, this 0 must be present at the end. Because numbers like 10, 20, 300, 4,000, 10 lakh, etc., all of them are divisible by 10. Why? Because that's the divisibility. If the number ends with 0, the number is divisible by 10, right? So I must block 0 at the end. That is why I'm saying there is only one way of doing it. One way. Put 0 there, right? Now what is happening? You have 5 digits remaining. You have 5 digits remaining, 137,579, and you have 5 places to fill. All right. Either you can use multiplication theorem, like this digit can be filled in 5 ways, then next one in 4 ways, then next one in 3 ways, then 2 ways, then 1 way. Or what you can write, you can say that it is like arranging 5 different places, 5 different objects at 5 different places, so 5p5. Alright, so that will be the answer, 5p5 or 5 factorial. 120 will be the answer. So this is the total number of numbers which can be formed by 0, 1, 3, 5, 7, 9. No digit is repeated. There will be 6 digit numbers divisible by 10. That is the meaning. Okay, let us take the last question for today. This will be the last question. And with this, we have completed PNC here. Okay, we'll start with complex numbers. All right, we have to complete complex numbers, and there is one more chapter called straight lines in this month. All right, with or without meaning, with or without meaning. Each of 3 vowels and 2 consonants can be formed from the letters of the word involute. Involute. Last question. You have to form the words with or without meaning. All right. That means arrangement will be done. And here we have this word involute.
Sir, can you spell up a little?
Can you please repeat?
Sir, can you just scroll up a little?
Yeah, sure. See, in this question, explanation is important. You might not understand what I have written when you read it later on. Okay. But you should understand how 5 ways are coming, why there is one way at the end, and how I am writing the remaining ways. Okay. And then why answer is 120. It is based on arrangement. All right.
Got it, sir. Thank you, sir.
All right. Okay. So this last question. Vowels and consonants. The vowels are I, O, U, and E. Let us write them here. I, O, U, E. These are the vowels present here, and the consonants are N, V, L, T. All right. Now, basically, we have to arrange because we have to form the words, but there is limitation that 3 vowels and 2 consonants should be there. So that means it is a 5 letter word. Okay, 5 letter word. 5 letter word containing 3 vowels and 2 consonants. So first of all, 3 vowels. First of all, 3 vowels can be selected in how many ways? Who can tell? In how many ways we can select 3 vowels?
So 4.
4 or 4?
4.
4C3.
Yeah, 4C3 or 4 both will be same because the value of 4C3 is 4 only. You have 4 different vowels, you have to select 3. Now, 2 consonants can be selected in. 2 consonants.
4C2.
4C2.
Yes, 4C2 ways. In 4C2 ways. Therefore, number of ways in which we can select three vowels and two consonants. That will be their product, right? 4C3 into 4C2. Therefore, now I want the last step. Therefore, total number of words formed from these five alphabets. Because basically you have selected five alphabets, right? Three vowels, two consonants. So total number of words formed from these five alphabets equal to how much? Can you tell me? Anyone? That will be the last of this answer. See, what is this value? Let me write the value also. 4C3 is 4, 4C2 is 6, this is 24. So number of ways in which we can select three vowels and two consonants is 24. But this is not the answer. We have simply selected. We have to form the words from these five alphabets. And the words may or may not have the meaning. So now who can tell me what is the last step?
24p5.
Not 24p5. You don't have 24 objects. You don't have 24 objects. 24 are the number of ways in which you can select five objects, right? You know what is this 24? It may be like that. See, you may have alphabets I, O, U, and you may have these consonants N and V. So I, O, U, N, V. This is one way. Then I, O, U, V, L, second way. I, O, U, V, T, third way. Or you can say O, U, E, N, L, fourth way. So in this way, we are getting 24 ways. So this is just selection. So 24 are the number of ways in which you have selected three consonants and three vowels and two consonants. So now you have five alphabets. You want to arrange them in a line. In how many ways you can do it? So this will be 24 into 5p5 or 24 into 5 factorial. That is 24 into 120. Whatever is the answer? Why? Because first you have selected five objects. Okay, with the restriction that three vowels and two consonants are there, and that thing came out to be 24. So 24 are not the number of objects, they are the number of ways in which you have selected five alphabets. Now you want to write them in a single line. So for them they can be arranged in a line in 5p5 ways. Not 24p5, 5p5, because ultimately you are having five objects. And those five objects are coming in 24 different ways. Because there will be 24 different combinations of the alphabets, right? So arrangement will be done in 5p5 as only. 24 is the value which you have obtained from the earlier part of the question. That means selection of the vowels and consonants. So 24 into 5p5, that will give you the final answer. Okay. So I hope this last thing is clear to you. This was the explanation of this question, and that is the end of the class as well. Chapter is over. Okay. Next class will be of complex numbers. That's it for today. Thank you.
So can you zoom out? Thank you, sir.
All right.